In this segment, we're going to talk about the problem of open domain QA, or so-called retrieval-based approaches to QA. So the type of QA that we've been talking about, we've established is very artificial and is vulnerable to all sorts of attacks when you introduce more complicated data. And it's not what we want, right? Like if you're Google and you're trying to answer questions that people are typing into the Google search bar, you're not answering just based on a paragraph. You're trying to answer based on the whole web. And so if someone asks you what was Marie Curie the recipient of, you might have to deal with more complex contexts that don't match this question as easily. So for example, Marie Curie was awarded the Nobel Prize in Chemistry and the Nobel Prize in Physics. And then you'll also have a lot of other distractors which are tricky. If you're looking for kind of other things that people are awarded on the web, you'll get Mother Teresa received the Nobel Peace Prize. Curie received his doctorate. This is about Pierre Curie, right? So this is also something that you would probably retrieve from Wikipedia, especially since Pierre Curie and Marie Curie are going to be mentioned in each other's Wikipedia articles. Sklodowska received accolades for her early work. That's her maiden name before she took the name Curie. And so again, we've got much trickier contexts to deal with if we're just grabbing these paragraphs from all over the web. So how do these systems work? What we do is we have an information retrieval system that's going to retrieve some documents, and then we're going to apply our reading comprehension QA model to actually try to answer the question. So in the DRQA paper, which we've talked about basically for its reading comprehension extraction part, they also address this other part of the question, answering over Wikipedia. And so they use a document retriever that basically uses a kind of essentially TF-IDF standard information retrieval techniques. And what they find is that they're able to get the answer in the context for various types of questions, roughly 70 to 80% of the time. And now notice we have Squad here. This is a variant of Squad called Open Squad, where we're answering over all of Wikipedia. Okay, so you're able to at least get the answer in there 75% of the time, but the data actually, the task is actually much harder. And so the numbers are a little bit cropped here, but you can see in the individual paper, all of these values are kind of between 20 and 40% accuracy. So the information kind of isn't there or is easily accessible, or there are much more confusing distractors in the context. And so suddenly we're not at 90% human performance, we're much lower. All right, so there's been work since that earlier stuff, in particular how to do this with BERT. And so there's some very nice work out of Google by Lee et al., where they looked at using BERT to actually encode every single paragraph on Wikipedia, and then also encode a question with BERT and use that to retrieve the relevant paragraphs. So they're not doing the reading comprehension step. That's not what they're doing here. Instead, they're using BERT for retrieval. So this is very powerful. BERT, besides big contributions in NLP, it's also revolutionized the field of IR, but it is also very slow. You have to pre-compute BERT over your whole, over basically all the web or whatever you want to index. That's very slow. And then also, if you want to train this thing to learn parameters that are going to let you do this matching better, you face a very difficult training problem. So there's been a lot of work from both Google and Facebook kind of handling this stuff, but it's at a much larger scale than is possible for most academic researchers to work at. All right, and the last sort of type of question, which I'll call out here, is a departure from the idea of these data sets like Squad, which are very much focused on an individual passage. So many of the squad questions actually can't even be answered with all of Wikipedia because it'll be like, where did the Super Bowl take place? And it's like, okay, well, in the passage it was just talking about Super Bowl 50. Now what Super Bowl? There's like, over Wikipedia we don't know. So Google released this nice data set called natural questions, which are real questions typed in by users that are answerable with Wikipedia. And they have both short answers, which are just basically span extracts like what we saw before, and longer answers, which are bigger snippets of a passage, maybe 1 or 2 or 3 sentences that contain the answer. So this question answering is much messier. In this case, there's not a short span answer. You have to give the longer answer because the answer is long and complicated. But this is actually getting at the kind of original goals that we had, which is being able to answer these questions like what temperature do I cook chicken to, which might have a longer and more complex answer. So the F1 scores on these data sets are much lower than on Squad. Like I said, on Squad it's over 90, and here it's 60 to 75. Human performance is also lower, but this is a kind of nice setting for question answering models that we know corresponds to a real problem because these are real questions that users typed in. So this is a data set that's attracting a lot of attention over the last year or so and represents one of the frontiers of QA in terms of this retrieval-based or open domain QA approach. That's it for this segment.